Good morning, students. Let me consider another type of getting the solution for our differential equation, that is in extended Taylor series expansion. Now we shall go to another type or method to find the solution for any periodic function. This is called by Fourier series. For that purpose, the definition of periodic function we shall see. A real valued function f of x is said to be periodic of period capital T, refer here capital T, if f of x plus t is equal to f of x for all t is greater than 0. What does it mean? When the given function is replaced by variable plus t, I mean the period. If there is no change, it is called a periodic function. You are getting my point? T is the period. For example, any constant term k, I mean real valued constant, sin x and cos x are periodic functions of a period pi, as sin of x plus 2 pi is equal to sin x. Here what is capital T? 2 pi. Here cos of x plus 2 pi is equal to cos x, since 2 pi is equal to t, and the constant term is no change. Okay. Next, the trigonometric series and the Euler's formula. The function constant cos nx, sin nx for all n equal to 1, 2, 3 and so on are all periodic functions of the period 2 pi. Then take k is equal to a naught by 2. Then the function is of the form a naught by 2 plus summation n is equal to 1 to infinity a n cos nx plus summation n is equal to 1 to infinity b n sin nx, where a naught, a n, bn for all n equal to 1 to 3 and so on are all constants is called a trigonometric series. This is called the trigonometric series. Here the period is 2 pi, because for any Fourier series the period should be noted. Here it is 2 pi. Then the expressions a naught equal to 1 upon pi integration between c to c plus 2 pi f of x dx, and a n equal to 1 upon pi between c to c plus 2 pi f of x cos nx dx, and bn equal to 1 upon pi c to c plus 2 pi f of x sin x dx are called Euler's formula. Okay, refer these three as very important results. Here, for this purpose, before going to apply these three results for our example, let me consider integration by parts. What is integration by parts? Integration of u into v dx equal to, that is a product of two terms, is given by u v1 minus u dash v2 plus u double dash v3 minus u triple dash v4 and so on. Here u dash, u double dash, u triple dash are all respective derivatives. v1, v2, v3 are all respective integration. Okay, let me consider another two examples as we have shown here. These two results are only the results you can know, not to go for any proof here, because these results are taken from your PUC second year. And sin n pi is equal to 0, cos n pi equal to minus 1 raised to n. Again, these four results are important, I mean frequently using while solving the examples. Let me consider one example where f of x is given by pi minus x upon 2 between 0 to x is less than 2 pi. What is the period here? The period is given by end point minus initial point, 2 pi minus 0. What is 2 pi minus 0? That is 2 pi. Therefore, capital T equal to 2 pi. And for any example, you write the Fourier series as we have shown here. Therefore, and a naught, a n and bn we need to write in particular, because the period is 2 pi as we have shown here. Then go for the integration 1 upon pi between 0 to 2 pi, pi minus x upon 2 dx. Keeping 1 upon 2 pi outside, take the integration pi into integration of dx is x, minus x is given by x square by 2, between the upper and lower limits are given by 0 and 2 pi. Therefore, its value integration reduces to 0. Similarly, a n 1 upon pi between 0 to 2 pi, pi minus x upon 2 is to cos nx dx. Here it's a product of two terms. Let me consider the Bernoulli's form of the integration as we have shown in the previous page. Okay, therefore a n is equal to, keeping 1 upon 2 pi outside, u into v1 minus u dash into v2. Just observe here, u dash into v2 between 0 to 2 pi. What is u here? Pi minus x upon 2. What is integration of, what is v? v1 is integration of cos nx, that is sin nx upon n. Therefore, u into v1 minus u dash into v2. Integration of sin nx is what? Minus cos nx upon n. 1 n is already here, hence it is n square. And differentiation of pi minus x upon 2, this much is minus 1. Therefore, minus 2, 1 upon 2 pi n square cos nx between 0 to 2 pi. Therefore, this is given by again 0. Please consider that sin 2n pi and sin 0 are 0. And cos 2n pi and cos n are 0 is equal to 1. Cos 0 is 1. It is known by you. Therefore, n is equal to 0. Similarly, go for bn. 1 upon pi between 0 to 2 pi, pi minus x upon 2 sin nx dx. Again, by the Bernoulli's form of the integration, u into v1 minus u dash into v2 between 0 to 2 pi. Therefore, while going the integration, keep the term that u shall be taken in such a manner that it should become 0 after first, second or third derivatives. And obviously the other term will become v. v1, v2, v3 are all respect to integration. Therefore, putting the upper and lower limit, going for the integration, this will reduce us to 1 upon n. Therefore, putting a0, an and bn in the first result, the result is, this is the general condition we need to substitute. Therefore, since a0 and an are 0, only bn is equal to 1 upon n. I am substituting bn is equal to 1 upon n. Thank you.